All right, so today we are going to get ready. We're going to review for the test, right? We have a test coming up on Thursday, is that right? So, but before we do that, I was right in the middle of doing the Java map demo, so let me just, for sake of continuity, finish that up and then we'll start reviewing for the exam. Here on this slide, you remember, let's just review a few characteristics that we saw because so that we can relate this to the code that we're going to do, that we're going to look at. First of all, notice that in this first part of the slide, the user entered lowercase m, lowercase a, and then uppercase r and uppercase s, and enter, and the software did not care about the uppercase, lowercase, and furthermore, it printed it out, when it printed out planet Mars, the M was capitalized, all right? And it does that similarly for all the planets. You can, whatever the case of the letters is, it standardizes them all. All right? And by the way, have you guys noticed that in your assembly language programs, when you write your mnemonics, have you noticed that you can not capitalize them? And when you do format from, and it takes it doesn't, uppercase, lowercase doesn't matter on the mnemonics. For example, if you write STBA like this for store byte accumulator, the assembler will take that. That's valid. And if you format from source, they'll be all uppercase. So you see, this is the same kind of thing. Whatever case you put in for the letters, it converts it to a canonical case. And so not only does it echo a little phrase about the planet with the planet's name in the phrase, it also gives two pieces of information, an enumerated output and an ordinal output. So those are features of the Java enum type. So let's take a look at the code that does this. So on this next slide, we have public enum planet. So now, we've seen these enumerateds before. It's in its own file, right? Is everybody clear? And so the name of the enumeration is planet, and you just list them in order. And what happens is each one of these has an ordinal value. So if we come back here to Mars, the ordinal output was 3. And if you start with Mercury at 0, Venus 1, Earth 2, Mars is 3. So it's in order starting at 0. Okay, that's the ordinal value. And it also has the ability to echo, the enumerated output, so that P underscore Mars. So so that defines the enum. So in a separate file, we have public class maps. Okay, now here's the thing, you guys. A map is also known as a dictionary, and it's based on a key value pair. Okay, so maps are key value pairs. All right, and the key is what you use to look up. The key is the first one, and that's the key is the item that you use to look up the information in the value. So this is for lookup. You look up based on the key. You look this up. You look up based on key. All right, and then the value is what you get. So this is the value is the value for the key is retrieved. Value for key is retrieved. So what we have here is we have two kinds of maps. We have so here we have public class maps, and we have two kinds of maps. We have a planet table and a planet string table. So do you see where those are right after class maps? We're going to have two different kinds of maps. And on one of these, the key is going to be a string, and on another one, the key is going to be the enumerated type. Does everybody see how these are divided? Okay? Because in some instances, we are going to have the enumerated type, and we are going to want the string. In other instances, we are going to detect the string that the user inputs, and we're going to want to store the enumerated type. And in your project, you will have both kinds of maps. Does everybody see how that works? So the first map, the planet table, notice it says public static final, and then map is the Java map container. And then we have these angle brackets, string, comma, planet. So you see capital S string, that is, in that case, the key is a string. So what you use that map for is you have a string and you want to look up the enumerated value that corresponds to it. Are you with me on this? Okay. And then on the other one that's called planet string table, the key is the what? Is the planet. But what is planet? What is planet's type? It's enumerated. You see? So the question is what you're given and what you're looking up. All right? And so we have both kinds. And so now what we're going to do is we are going to populate these maps with the keys and the values that we want to be able to look up later in the program. And what you're going to do, the reason this is going to be relevant for your project is you're going to have a whole list of identifiers that correspond to mnemonics. And so you'll do table lookup. So you will store your mnemonics in a map. You see, that's what your application is going to be. All right. So let's take a look at how planet table is populated. So we say static. Now, what does static mean in a programming language? Yes, one per class instead of one per object. So we say static, and we say planet table gets new hash map. All right. And the reason this is a hash map is because the key is a what? What is the type of the key? It's a string. Now I know that not all of you guys have had data structures, but do you remember when we hashed strings? So this is a direct application of what we did, constructed ourselves in data structures. When the key is a string, you use a hash table. All right? But look, and what we will see later on is if the key is an enum, you don't have to hash the key. It's just it has an ordinal value. It can be just like an array, and you just look up a string. See? Does everybody see what the difference is? So here in planet table we have new planet table gets new hash map, and then there is a method called put for a hash map that puts the key value pair in the dictionary or in the container. So you see planet table dot put and then parentheses and then Mercury. Now how did we capitalize the keys to be all what here? All lowercase. And so you see Mercury is the string key that goes with the enum value planet.p_Mercury and so on for the rest of the planets. Does everybody see that? So now we have to know whenever you set your maps up, you'll have to do uppercase, lowercase, and be consistent, however you want to do it. All right? You do all uppercase or all lowercase or whatever. Okay? And now here for the planet string table, notice this is not a new, what did we have for planet table? We said new what? Hash map. But here for the planet string table, what do we have? New what? Enum map. Now why is that? That's because in this case the what? The key is an enumerated type, and so the way we use this table is we give it the key and we look up the string. But now look at how we are storing the strings. How are we storing the strings? The string values of each enumerated. The way we want what? Yeah, the way we want it to be printed out. So in your project, when you go through and you find these identifiers, when your lexical analyzer gives you these identifiers, what you'll do is you'll set up a map, you will look them up in a map, and the string value that you will store in the enum map will be all uppercase, because that's this canonical way to print the mnemonics. So even if the user enters a lowercase letters, you'll print it out in all uppercase. So your user can do format from listing, if from your listing. Okay. So here again is planet string table gets new enum map, and then and it's planet.class. All right, and then we do planet string, and the string, because it's a planet string table, we know that because it's an enum map, we know that the key is an enum, and so we do planet string table dot put planet.p Mercury, and then we write Mercury the way we want it to be printed out, all uppercase and lowercase the way we want it. Okay, so now that is in a separate file, and now how do we this is the code, this is the action performed that actually does the lookup. All right, so it's public void action performed. String line gets text field dot get text, so that's, we've done this before. And now check this out. If this is a slick if statement. If maps dot planet table. Now, which one was the planet? The planet table had what for the key? The string, right? So if maps dot planet table dot, and there is a method called what? Contains key. And what are we giving it? Contains what key? Line. And what is line? That's that text field. But we remember how we stored them all what? Lowercase. So we give it line dot to lowercase. So whether the user entered it in uppercase or lowercase, we are checking it with the lowercase keys that we stored in the map. Does everybody see how that worked? And that's either true or false. And if it's true, what do? We have a local variable named lowercase p planet, which is of type what? Uppercase p planet, which is a what? An enumerated. And that planet gets what? Now stop planet table. So now what is what is the key for planet table? Yeah, it's a string, right? Planet table was a string, right? And so we give it the lowercase version of the line so that we can look it up. And now planet is that enumerated type. Does everybody see how that's working? So now planet is that enumerated type. And then and now we have a string type, planet string. And what does that get? Maps.planetString table.get planet, because now what is the key? The key is the enumerated that we did before. And so this is returning our string, with the uppercase and lowercase exactly the way we want it printed out. And now we don't switch on the string. What do we always switch on? The enumerated. Okay, you always switch on enumerateds. So we switch planet, and planet is the enumerated value. Okay. Yeah, question?
When you say like we have like...
Yes. No, enumerateds are, switch is always with integers and enumerateds.
Okay.
Yeah. Switch is always on it with enumerateds. And enumerateds are like integers. It switches on their ordinal value is what it does. Okay. And so look, we print out the same thing if we get Mercury or Venus is close to the sun, and then Earth, planet is and what does it say? Let's take a look at Earth. System.out.printf what? The what? %. So there's the placeholder for the string, but what is our placeholder for the string? Our planet string that we looked up from is everybody with me on that?
I guess.
All right, are we good with that? So that's the story of maps, and then system.out, and then else. And else is part of the if, right? So if contains, right? And if it doesn't contain, then what do we print out? Line concatenated with space is not a planet. So Texas is not a planet. Are we good? Okay, so that's maps, and that's data structure, a container, a Java container that you'll be using on your next milestone of your project. Okay, now what I'd like to do, I handed back some homeworks, And I think what I would like to do is go over, there were a number of errors on the last, not the last assignment, but the one I'm just handing back. This finite state machines. I think that would be a good review for the exam. But on the other hand, I don't want to give the I don't want to put the solutions out over the air, so I'm going to cut this out. Sorry, you guys out there in video land. Okay, so let's take a look, and then after that, I'll give you some guidance on what you can expect on the exam, in addition to this. Okay, so now that I've given you those solutions, for the remainder of the time, I want to tell you how to study for the test, some tips on how to study. First of all, I mentioned the other day that the Java code, all of this Java code for your project is not, I'm not going to ask you any Java code. I'm not going to ask you to do any implementing finite state machines in Java. None of that's on there. The project is kind of like a separate, project that's I don't want to test you on. There's too much other stuff. Yeah.
So we won't implement any finite state machines?
You will not implement any finite state machine. A table lookup, direct code technique, that stuff about multiplying times 10 and blah, blah, blah. I'm not going to ask you to do any of that code. I know you're used to writing code on the exams and data structures, but not with this, not this project. Okay? Yeah.
So, like, no coding, as in none of the coding projects, like, we won't have to memorize any code?
No code from the project.
Or any of the homeworks, like, coding that we actually, projects that we did, like, but not the big...
Okay, yeah, now, there is going to be some code.
Okay.
Let me explain what the code's going to be. Okay, now, we started, here, actually, let me bring up the slides. Okay, so here in this slide, this is where the material started. It's symbols, okay? And so here's the code. Let's take a look at these slides and see what it is that you need to be able to do. Okay, you see this figure 515? This figure 515 has an assembly language listing with symbols in it. And you see there are 1, 2, 3, 4, 5. There are 6 columns. There's the address column, the object code column, the symbol column, the mnemon column, the operand column, and the comments. I will give you an assembly language program, and I promise I'll do this. This is one that's going to be on there. I will give you an assembly language program with the symbol column, the mnemon column, and the operand column, and you will have to fill out the addressing column and the object code column, and you should be able to produce this symbol table. Okay? So the symbol table, now tell me, in general, what did we say is the value of a symbol? The value of a symbol is an what? Address. And addresses are always written in what? Hex. Always written in hex. Okay? So you need to be able to, well, except there's one exception to the rule. What dot command does not generate code and for which the symbol is not the address? Do you remember which dot command that was? Ooh, nice review here. Yes, dot equate. Remember, that was the exception to the rule. Okay, so here, let's review this figure 5.15. What is the value of main? Yes, it's 005. That's because the code that's generated by main, the DESI, which the code that was generated was 310003. That 31, it starts at address 0005. So here, if we go down to the symbol table, main has the value of 0005. Does everybody see that? So what I recommend you do is take these listings or go to the PEP9 app and look at the source code, copy, do copy to source, and before you do the build, see if you can translate, do all those translations, and see if you get what the code shows. All right. So that will be on there. All right. And then there will be a translation program. So here, let's do you need to know how to translate an assignment statement. So this is the kind of code that'll be on there, right? It's how to translate an assignment statement. So here, let's do an example. Figure 5.27 would be a good one to study. Const int bonus equals 10. Int exam 1, int exam 2, int score. Could you translate this into assembly language? How would you do it? Okay, what about exam 1, exam 2, and score? What kind of variables are they? Local or global?
Global.
Global. So therefore they are stored where?
At a fixed location.
At a fixed location in memory. And they are allocated with what? Dot what? Exam 1 what?
Block.
Exam 1 colon dot block what? 2, because 2 bytes for an integer. And is bonus allocated with a dot block, yes or no? No, because then here's where the equate comes in. Instead bonus equates to what? 10. All right? And how did we do score gets exam 1 plus exam 2 divided by 2 plus bonus? Here, let's do it. Let's verbalize it. How do we do that? Load accumulator what? No, not score first. Exam 1 addressing mode? Direct. Okay. And then what? Add accumulator, exam 2, direct. And then how do we divide by 2? ASL accumulator. L, I think left. No, wait, is that right? Oh, no, sorry, right. You're right. Sorry, my mistake. Yeah, so ASR. And then how do we add bonus? Add accumulator bonus addressing mode. Immediate, because bonus is not a variable. What is it? It's a constant. And how do we know what its value is? It was equated to 10 with the dot equate. And then after we have that done, what do we do with that? What's the last instruction? No, not load. Not load. Load is the other way. Store. And then store. Okay, so here. And we went through this. So you need to be, I'll give you a translation program like this. So know how to do that. Know how to do the, and the immediate addressing, direct addressing. And here, do you see that, here, tell me if we look at the symbol table, what will be the value of main? 0009. What will be the value of exam 2? 0005. What will be the value of bonus? Actually, if we write it in hex, it will be what? What kind of 10 is that? What kind of 10 is that? Decimal or hexadecimal? Because it doesn't start with a 0x. So, but its value is always written in hex, so what will that be? 000A. So let's see if we did it right. Bonus 000A, exam main 0009. Is everybody clear? Okay. And don't forget the von Neumann cycle. A program might modify itself even if it has symbols in it. And basically, you guys, I can't emphasize this enough. Know how to do all the exercises. Okay, what I recommend you do is know how to do the exercises. We did some of them here with the finite state machines, but all the I recommend you review the exercises. Word to the wise. All right? I think that's about all I had to say. All right, so good deal. Good luck on, I'll see you on Thursday.